Greetings. I thought I would make a quick video where I just respond to some of this big think. I've been seeing a lot of this where Bill Nye and others come out and try to rebuttal flat Earth. What inspired me to make this video is when Michelle says that it's not okay to think that the world is flat and that she knows people that have done this or that. It really disturbs me that a scientist would say that it's not okay to question where we live. We should be questioning everything. That's the beginning of knowledge. I always end my videos where I encourage people to question everything, question what I'm saying, and do your own research. And it really bothers me when a scientist says it's not okay to question something. You should definitely be questioning that at that point.
It's not okay to think that the Earth is flat. This is not a viable argument. I have friends who have been on the International Space Station. They have orbited the Earth once every 90 minutes. You know, I have had personal experience with people that have been up in space and can see with their own eyes that the Earth is round. And of course, we've taken all these amazing pictures from space. They're so beautiful, all those pictures of the Earth.
Is the Earth flat or round? It's round. Okay, now let's see. How do we go about proving that? Go to the seashore. Go to a seashore and figure out why you can't, if you live on the East Coast, figure out why you can't see Spain.
Looking horizontally across the Earth, there are many limits due to mostly the atmosphere conditions that are not factored when looking upward towards the star, like perspective, vanishing point, angular resolution, humidity, and the atmosphere itself. The atmosphere is like really thinned out water. So if you can imagine being the end of one large swimming pool and opening your eyes underwater and trying to look across that swimming pool to the other end, you can't always see the other end of the swimming pool. Our atmosphere works the same way.
The higher you are off the sea surface, the higher you are off the sea surface, the farther you can see, the farther away the horizon is.
One of the things you can see yourself with a pair of binoculars is if you actually go out to a lake and there are boats on that lake, the farther away a boat is, the more the bottom of the boat will disappear and you'll basically just see the mast of the boat. And as a boat goes farther and farther away, the last thing you will see is the very top of the mast of that boat. And that's because the boat is actually going over the horizon that's curved. And that means that as it goes farther and farther away, you see less and less of the bottom of it and more of the top of that. You can see that with binoculars, by an ocean, by a lake. It's really easy.
If a ship disappears over the horizon at 3.5 miles, how is it that to the left and to the right, one can see a total of 7 miles, 3.5 miles to the left and 3.5 miles to the right, and see no curvature, just a flat horizon that always rises to eye level? Why is it that the ship appears to remain vertical? Shouldn't one notice that it starts to arc away from the observer? A ship disappears from the bottom up due to perspective and angular resolution. If the observer rises up, then he or she increases their perspective or increases their aperture, if you will, and their angular resolution limit will be further away. The top of the ship has a greater angular limit than the bottom of the ship. The bottom of the ship is at sea level, and so the angular resolution would be less than the top. So naturally, on a flat surface, as an object moves away from an observer, it should become unresolvable from the bottom up, as the bottom of the object has less angular resolution than the top of the object.
If you'd like, look at pictures from space where you see the Earth as a sphere. Those pictures are not faked. And I'll tell you, just if nothing else, here's why you can tell they're not faked. Just to create the paperwork that NASA has created, for NASA in this one case, just the paperwork to send anything out in space, to send people into orbit or to send them to the moon, that amount of paperwork would make faking it prohibitively expensive. No one could afford to generate that much documentation.
And of course, we've taken all these amazing pictures from space. They're so beautiful, all those.
It is photoshopped, but it has to be.
Space art in the galaxy. In a small, bright office, working side by side,
Let's see.
Robert Hurt and Tim Pyle bring the universe to life.
What we're doing does have real science underlying it.
Robert is an astrophysicist turned artist. Tim, once a Hollywood animator, is now a planet illustrator. Together, they produce some of NASA's most popular images, from renderings of how planets light years away could look, to actual photos of stars and galaxies captured by NASA's powerful telescopes.
And this is sort of how it comes to me. And then I
Many of those images have a dark, grainy start, but color and light reveal an astonishing glimpse of how the deepest regions of space might appear to the human eye.
What I'm trying to do is show people sort of the broader colors that the universe has to offer.
It's a delicate blend of imagination and data. The artists meet with NASA scientists over many drafts to ensure a planet or galaxy's look lines up with the research to make each one as accurate as possible.
I love the challenge. It's kind of like a puzzle to me of trying to create something that looks really cool within the restrictions that were given by the scientists.
It can take days, even weeks, to produce just a single image. The dazzling final results, enough to keep us all dreaming of the final frontier for years to come.
So in conclusion, thank you for watching, and I want to encourage you to question everything, do your own research, especially when somebody tells you it's not okay to question something. You should definitely be questioning that particular thing. Hope you enjoyed the video, and as always, have a great day.